Hello everyone, this is Ahmed Jahaz again, and today I'm continuing the discussion about foam as a firefighting agent. In earlier videos, I spoke about what is foam and how is it used in the fire protection industry, especially in process facilities, oil and gas, refineries, and chemical plants. And also, I made a video about uh, one of the commonly used foam fixed systems for storage tank protections, which was the top injection foam system. And today's video is about the other type. So there are three main types or three common types used for fire protection of storage tanks related to foam. And today's the other type, one of the three types, the subsurface injection system. So as I said earlier, fixed roof tanks. So there are the fixed roof tanks and there are the floating roof tanks. And the construction or the design or of the tank depends on the type of material stored inside, the flash point and the physical and chemical properties of that liquid. So in general, fixed roof tanks store combustible liquid. So there are two classes two main classes as per NFB 30 of flammable and combustible liquids. There are the flammable liquids that have the flash point below 38 degrees Celsius, and there are the combustible liquids that have flash point at or above 38 degrees Celsius. There is more details, but in general, that's it. And the type of foam stored, the type, sorry, of the liquid, is it a normal or regular hydrocarbon, or is it liquid which is polar solvent or alcohol based? So this information is important, so to select the right type of foam to be used in order to put out a fire in such fuels. Now going back to our main topic for today, the subsurface injection. So it is one of the two systems that are designed to protect fixed roof tanks. The subsurface injection will inject and will facilitate the entry of foam at the bottom of the tank, just above the water level. Water level hydrocarbon tanks storing hydrocarbons, oils, usually will have some kind of water layer at the bottom of the tank. This system will inject it above the water layer, at the bottom, but above the water layer, because you don't want foam to go through the water layer. Otherwise, it's gonna destroy the formation of the foam. So foam is injected at the bottom of the tank, either through a full fixed system. That means that the system is attached to a foam supply, or through a semi-fixed system. That means that the foam is transported to the location of the tank through the fire trucks or foam tanker, and some kind of interference by the emergency response must be done. So one of the advantages of such system is that it is not at risk of damage when an explosion happens at the top of the tank. Most likely, if an explosion happens in a storage roof tank, a vertical storage roof tank, it will happen at the roof area. It will happen in the vapor space above the liquid level and under the roof of the tank. An explosion will happen and a fire will be resulted from that explosion. So this system is not at risk from damage, as opposed to the top injection system or the rim seal fire protection system, which is located at the top of the tank. And when the explosion happens, there is a possibility that such systems will be damaged. Then the emergency responders will be forced to use a manual application of foam, which is the subject for another video, a coming video. So one of the advantages is not going to be damaged if an explosion happens in a tank. Another advantage also, it enables us to minimize the foam loss as opposed to applying foam manually. So most of the foam will be delivered to the fire. Uh, Going to the limitations of such systems, these systems are mostly found on storage tanks storing regular hydrocarbons and hydrocarbons with low viscosity. And hydrocarbons with high viscosity, having such system is not advised. As I said, it will also cause the destruction of the foam formation when the foam is entered to a tank that have hydrocarbon with high viscosity. Also, it's not advised and not recommended for tanks. It's not permitted actually for tanks that is storing polar solvent or alcohol-based flammable or combustible liquids, because these type of liquids are destructive to the foam formation whenever the foam is injected through or mixed with such liquid. One other thing that the subsurface system is either a fully subsurface system or a semi-subsurface system. So the subsurface system, as I said, I explained the same, explained earlier how we inject foam and how does it deliver foam inside the tank. As for the subsurface system, it's the same. However, there's some kind of duct that is connected to the system inside the tank that will float if foam enters through it, and it will float until it reaches the top of the burning surface of the liquid, and it will deliver foam at that area. That means it's not going to go through the actual liquid. It's not going to go in contact with the actual liquid. However, it will go through the duct that is inside the tank, and it will float to have some kind of buoyancy because the foam contains some kind of air, a little bit of air, and it will float when foam enters, and it will allow foam to uh, be delivered at the top of the tank. These type of systems can either be delivered. The subsurface system can be done through a product line, an existing product line that can be utilized during an emergency, or it can have a dedicated foam line. So we have you can find it in three in two designs. Either it can be utilized through an existing product line, and this product line has the facility to connect the foam and deliver it to the tank, or it can have a dedicated subsurface foam injection line. One specific device must be used for such systems, which is the high back pressure generator or maker. This device allows us to introduce air into the foam solution that is coming from the fire truck. So the emergency responders will arrive with their fire truck, and the fire truck contains the foam concentrate. They will connect water supply and supply the fire truck with water, and the fire truck will have the facility to proportion the concentrate foam into the right portion of water, and foam solution will be delivered to the inlet. At the inlet, the fire either there will be some kind of high back pressure device fixed, or the firefighters or the emergency responders will install the high back pressure generator and will connect it to the product line or the foam line, and will inject foam solution through it. This high back pressure generator will allow air to be introduced to the line, to the foam solution, in order to give us the expanded or the firefighting foam that is needed to be injected into the tank. This is taken from NFPA 11. This is a typical foam high back pressure generator. And as you can see, there is an air intake that will allow air to enter to the high back pressure generator, and the foam solution will be coming from the fire truck via hose and through the high back pressure generator, and air will be mixed and it will enter through the system, either a product line or a dedicated foam line. The application rates and the discharge time, I will come to it in the next slide. As we said, we need to discharge the foam above the water level, otherwise the foam will be destroyed. And also this system, when it's a fully subsurface, not the semi-fixed semi-subsurface system, the subsurface system, it will help rolling a cool product to the surface of the burning liquid. This will help in many ways. It will circulate the product inside and prevent the formation of a hot product layer. And I did mention this situation happening in crude oil tanks that will cause an ugly event that is called the boil over. You can check it in the other videos in my channel. And also we must use the high backup generator. We also said that can be fixed in the system or either be installed by the firefighters when they arrive to the scene. And also I said that there is no risk of being damaged from an explosion, since the inlet is located at the bottom of the tank. Now, sorry. Now, the application rate is same of the subsurface system is the same of the application rate of the top injection system, which is a minimum of 4.1 liter per minute per square meter. Yes, you can exceed, but I think the limit is 8 liters per minute per square meter. In some situations, you need to exceed to that, to the maximum application rate, especially when the fire has been left burning for some time. So what are the discharge time? The discharge time depends on the type of product inside. So as we said, normally the liquid is stored inside are combustible. However, if there were flammable liquids stored inside the tank, then the discharge time should be 55 minutes. Flammable liquids that have flash point, hydrocarbons that have flash point below 38 degrees Celsius. As for combustible liquids that have flash points at or above 38 degrees Celsius, then the discharge time is minimum of 30 minutes of application time. However, it says here liquids requiring alcohol resistance foam, but I mentioned that these kind of tanks or this kind of system are not installed on tanks storing such liquids. However, this table is for the semi-fixed system, where I said that the some kind of duct will be here, a hose or duct inside the tank, and when foam is flowing through it, it will rise and pour foam at this area without allowing the foam to mix with the product inside. One other thing we need to mention is the minimum number of subsurface unit, and this, how many inlets should be installed in the tank. This depends on the size of the tank, the diameter of the tank. For tanks that are below 24 meters in diameter, then a minimum of one subsurface inlet is required. You can exceed that. However, whenever you add more than one subsurface outlet discharge, we need